Alright, so we're going to be talking about balancing chemical equations. We're going to use two guidelines to help us to balance these chemical equations more efficiently. First one is we're going to begin with a compound where it has the atom happens to be in one compound on the left and one compound on the right. And we'll see examples of that. We're also going to use this second guideline that the last one that we're going to do is we're going to do any atom that occurs as a free element. For example, O2 would be standing alone. It's as a free element. So those are the last ones. Okay, so we have priorities for first ones and last ones, and we'll go through each of the elements in the equation and make sure that they are balanced, having the same number on the left as they are on the right. Okay, let's go ahead and take some examples. You can see that this first one, we've got propane and its combustion reaction. And with any combustion reaction, it's reacting with oxygen in the air, and it produces an oxidized form of the original thing, in this case carbon dioxide, plus water as a byproduct. You're always going to have that as a byproduct for a combustion reaction. So let's go ahead and look at how many atoms there are of carbon on the left and how many there are on the right. We're starting with carbon because it's only in one compound over here and one compound over here. So here we see that we have 3 carbons in one propane. So we have 3 carbons on the left. Here we have 1 carbon in CO2. Now we need the same number of carbons over here as we have over here, which means we need to take the lower one and make it bigger. And we can do that, we need to make it 3 carbons. The way we can do that is we multiply this by 3. So we have 3 carbon dioxides. 3 carbon dioxide would give us 3 carbons. So if we have to multiply this by 3, that is our coefficient. 3 carbon dioxides. Okay. Now we have 3 carbons on that side, 3 carbons on this side. In fact, it does balance. Check, carbon's done. Now let's go on to hydrogen. Hydrogen is in one compound over here. It's in one compound over here. So let's go ahead and balance that. This propane has 8 hydrogens with it. So 8 hydrogens. Water comes in sets of 2. So each water gives you 2 hydrogens. But we have to have equal numbers on both sides. So what we need is 8 hydrogens on this side, which means we have to multiply this by 4. We need 4 waters to get 8 hydrogens. That means our coefficient here is 4. Now we're going to do the last one. The last one is oxygen. Not only is it a free element, but also it's in more than one compound on this side. So that's one of the reasons why we do it last. So this one comes in sets of 2, so 2 oxygens. And as it's written, we only have 1. Let's look at this side. We've got 2 compounds that have oxygen over here. So 3 sets of 2 for carbon dioxide gives us 6 oxygen. And over here we've got 4 water molecules. 4 water molecules gives us 4 oxygens. That gives us a total of 10 oxygens. Remember this was 2 oxygens. That O was for oxygen. So we've got 10 oxygens over here and only 2 oxygens over there. Well, we need the same amount, so we need 10 oxygens over here. We do that by having 5 of the O2s. 5 of the O2s gives us 10 oxygen, and it'll balance out the one over here. Now, so that's how we have a do our balanced chemical equations. And you'll notice that our final chemical equation not just has the coefficients balanced, but it also has the states of matter written in here. In this case, they're all G's for gases. So that's a complete balanced equation. Now, so you could balance this and get these coefficients as well. 2, 10, 6, and 4. Those could be coefficients for this chemical equation. They're not the correct ones because each one of these can be divided by 2 to get the numbers that are up here. So always double check to make sure you have the lowest ratio. There's nothing that you can divide all of your coefficients by in order to get lower ratio that are all whole numbers. So that's the reason these are the correct ones. If you accidentally put a 2 in front of there and balanced it, it may be balanced, but it may not be the lowest ratio of coefficients possible. So always make sure lowest ratio possible. Let's go ahead and do another one. Let's do calcium hydroxide plus HCl, hydrochloric acid, gives us calcium chloride and water. We have calcium, there's one calcium on this side, there's one calcium on this side. They're already balanced. Good to go. Now let's look at oxygen. There are actually 2 oxygens on the side. Remember, this is calcium, but there are 2 hydroxides with it. So if it helps that 2 to draw them out, go ahead and do that. The 2 here applies to everything in the parentheses, not just the H. It applies to O2, the O also. So we have 2 oxygens over here. Over here, we have 1 oxygen from water. Well, we need it to have 2 oxygens, so we need to multiply that by 2, which means 2 is the coefficient for water. Now, we've got H, but H is in 2 compounds over here. So we're going to use that bottom guideline and say, let's wait on H, and let's do the chlorine. Chlorine, there's 1 over here and 1 over there. So according to HCl, we've got 1 Cl over there. Calcium chloride, there are 2 chlorides here. So the higher number is 2, which means we need 2 chlorides over here, and we do that by multiplying this by 2. If we need 2 HCl's, we put 2 as the coefficient. Alright, now we've got calcium balance, oxygen balance, chloride balance. The only thing we haven't balanced is the hydrogen. We have 2 hydrogens over here from the calcium hydroxide. We have 2 hydrogens over here from the HCl, and that gives us a total of 4 hydrogens on the left side of the equation. Now over here, we've got 2 sets of 2 hydrogens from water. We have 2 waters, which gives us 4 hydrogens. 4 hydrogens, 4 hydrogens. Indeed, they are balanced. Okay. So this would be your balanced chemical equation for calcium hydroxide reacting with hydrochloric acid. Let's do another one to practice this. Here we get into a little bit higher numbers. We have some unusual situations. So let's go ahead and work with these. Here we've got carbon dioxide combining with water in a photosynthesis reaction to produce glucose and O2 as a product. Alright, let's start off with the carbons. There's 1 carbon on each side. This carbon dioxide only has 1 carbon, but the glucose has 6 carbons. We want to make sure they're even, so we've got to bring this one up to 6. We can do that by multiplying by 6. We have 6 carbon dioxides. Okay. Now, oxygen is in more than one thing, so we're going to wait on doing that. Hydrogen is only in one thing here and one thing there, so that's the next one we're going to do. This one comes in sets of 2, so every water has 2 hydrogens. This one has 12 hydrogens. Well, clearly 12 is the bigger number, so we want 12 over here. And that means we're going to need 6 of the waters in order to get up to 12. So our coefficient is 6 there. Now our carbons are balanced and our hydrogens are balanced. Let's move on to oxygen. Oxygen, well, we already have 6 sets of 2 here, so that's 12 oxygen from carbon dioxide. We have 6 oxygens from those 6 waters. 6 oxygens from those waters. You add them up, you get 18 oxygens on the left side. Now let's look at the right side. We have 6 oxygens from glucose. And here's our free element. So as it's written, we only have 2 oxygens because it sets of 2. Now, when we add these up, we only get 8 oxygens. So clearly we need more oxygens on this side. If we go back and change the coefficient of the glucose, we're changing our carbons and our hydrogens, which we don't want to do, because then we have to go back and do all those things. Or we can put any number in front of here, and it won't change the carbons and hydrogens. So that's what we're going to do. We're going to focus on this. So we're going to add so many of the O2s to get us to our 18 oxygens. And we've got 18 on both sides. So we can go ahead and solve this math problem. You subtract 6 from both sides, and you have 2x equals 12, x equals 6. So we need 6 oxygen O2 molecules. So 6 is our coefficient. 6 sets of 2 will give us our 18 overall. Okay. So let's go ahead and do this next one. This next one's a little different. This one's going to show us how we can deal with fractions. Because remember, we said that all those coefficients have to be the lowest ratio, but they also have to be whole numbers. Okay, so we're going to see that in this one. Okay, let's start by balancing it the way we did all the others. Okay, we have 4 carbons over here. We have 1 carbon over here. We know they have to be equal, so we need 4 carbons. We have to multiply this by 4. That means we need 4 CO2s. Hydrogens in 1 compound over here and 1 compound over here. Okay, we've got 10 hydrogens over here. We have sets of 2 hydrogens here. We know they have to be equal, so we have to bring this one up to 10, which means we will multiply that by 5. 5 is the coefficient here. So break this one. Now the one thing we haven't balanced are the oxygens. This is free elements, so it makes sense to do that last. So this one comes in sets of 2. And over here, we've got 4 carbon dioxides, each one having 2. So we have 8 oxygens from carbon dioxide. We have 5 water molecules. Each water molecule has 1 oxygen. So 5 oxygens from water. We add them up and we get 13 oxygens. Okay. Now this is the bigger number, so we need 13 oxygens over here. So what do we multiply by 2 in order to get 13? Well, it'd be really nice if we could do 13 halves, because then 13 halves times 2, the 2's would cancel out and we get 13. That would be what we would really nicely do, because then we're done. Unfortunately, that's not a whole number. So that doesn't work. So we could go back and put a 2 in front of here and then balance everything again. That would give us likely the right answer. If 2 didn't work in front of there, you could try a 3 and so on. But the easiest way to do this is to just get rid of that fraction. Now we can't just get rid of that fraction just by changing one thing. We have to do the distributive property in math. If we want to get rid of a fraction, we have to distribute it to everything in the parentheses. So if we can multiply this whole thing by 2, we'll get rid of that fraction. But we have to do it to the first one. We have to multiply 2 by the second one, by the third one, and by the fourth coefficient. So let me rewrite this equation without any coefficients. And now let's multiply through 2 times 1, because remember there's no coefficient there, it's just a 1. That makes that a 2. 2 times 13 halves gives us a 13 there. 2 times 4 gives us an 8. 2 times 5 gives us a 10. This is the complete balanced chemical equation for the combustion of butane. Keep in mind, all of these are whole numbers. We have no fractions as coefficients.